imibare. We are going to work together these questions by using the ratio test in testing whether the series converges or diverges. Let's start. For the series to converge or diverge, we find the limit as n approaches infinite of the un plus 1 over un. Assume this is a real number L, any number of your choice. Okay? The series to converge, this number must be less than 1. Here means the series is converging. When the number is bigger than 1, the series is diverging. Diverging. Now, let's start our question. But starting from the question A. As you see here, we have the question A is we have the sum as n starts from 0 to infinite of n power 4 over 3 raised to n. As you see, this is the general term un. Here, un is equal to n over 4, n power 4, sorry, over 3 to the power of n. What we need to do is to find the next term to un. Here, the next term to un is un plus 1. This will be got by replacing n by n plus 1. Here is n plus 1 to the power 4 over 3 to the power of n plus 1. This is equal to n plus 1 to the power of 4 over 3 power n times 3. Here is un plus 1. The next is to find the limit as n approaches infinite of un plus 1 divided by un. This is the limit n approaches infinite of, here is n plus 1 power 4 over 3 to the power of n times 3 divided by, here un is n power 4 over 3 to the power of n. This is equal to the limit as n approaches infinite guys, of n plus 1 to the power of 4 over 3 to the power of n times 3. Then let's multiply the reciprocal of this. It will be 3 to the power of n over, so here is only n to the power of 4. Now, the limit as n approaches infinite of the series, you see, this and this will simplify one another. We are going to have n plus 1 power 4 over, here 3 will multiply this n power 4 to have 3 power times n to the 4. This is the limit as n approaches infinite of 1 over 3, then n plus 1 over n to the power of 4. This is equal to the limit as n approaches infinity, guys, of 1 over 3, here is 1, into, inside the parenthesis, let's divide by n. N by n, that is 1, plus 1 over n. Now, we are going to evaluate the limit by replacing n by infinite. Here we have the limit as n approaches infinite of 1 over 3, 1 plus 1 over n to the power of 4. This is equal to 1 over 3 times 1 plus 1 over infinite to the power of 4. This is 1 over 3, 1 plus You know, any number divided by infinite, that is 0. Here we add 0 to the power 4. This is 1 over 3. 1 power 4, that is 1. 1 times 1 over 3, that is 1 over 3. And as you see, this 1 over 3 is less than 1. From this here, the number half here is less than 1. This means our series is convergent. Now, the series n from 0 of here is n power 4 over 3 to the n is convergent, and it converges to 1 over 3 and converges to 1 over 3. Here is the first question's answer. Let's try the next. Remember that this was A. The next is B, and our B is this. Let's try it together. Hope you saw everything here. Our next question is this, that is B. Our B is the sum as n start from 1 of the factorial of n over 2 to the power of n. As we started, this is the general term un. Here means un is equal to the factorial of n over to the power of n. Un plus 1 is what we are going to look for. You see, un plus 1 will be seen by replacing n here by n plus 1. This is n plus 1 factorial over 2 to the power of n plus 1. Okay? Now, un plus 1 is going to be n plus 1 times the factorial of n over 2 to the n times 2. This is from the fact that the factorial of n is equal to n minus 1 factorial. Now, let's evaluate the limit as n approaches infinite of un plus 1 divided by un. This is the limit as n approaches infinite of our un plus 1 is n, it is this n plus 1 times the factorial of n over 2 to the n times 2 all over our un was this is the factorial of n over 2 to the power of n. Now we have the limit as n approaches infinite of n plus 1 times the factorial of n over 2 to the n times 2. We are going to multiply the least product of this denominator, that is 2 to the n over the factorial of n. As you see, here on numerator you have 2 power n, and on denominator you have 2 power n. That's why we are going to simplify this and this. On numerator you have the factorial of n, and on denominator the factorial of n. That's why you are going to do like this. This is equal to the limit as n approaches infinite of n plus 1 over these two. Replacing by n, the limit is going to be infinite plus 1 over 2. This is infinite over 2, which is infinite. Since infinite here is greater than 1, this means our given series is divergent. The series you have here as n approaches 1 of the factorial of n over 2 to the n is divergent. That's it. Hope you're seeing this, and what I want from you is to share this live. Let's continue with the next question, which is our question C is the sum n from 1 to infinite of n plus 1, n plus 2 divided by the factorial of n. As you see, our general term un is n plus 1 into n plus 2 over the factorial of n. Let's look for the next term to this. We'll be replacing n by n plus 1. This is n plus 1, then plus 1, n plus 1, then plus 2 over n plus 1 factorial. Here is factorial, guys. I hope you see this. This is equal to n plus 2 times n plus 3 over n plus 1 times the factorial of n. We make this n because here we have the factorial of n, so that when making the derivation, it will be easier for us to simplify them. Okay. Un plus 1 by un. This is un plus 1 was n plus 2, n plus 3 over here is n plus 1 factorial. Sorry, n plus 1 times the factorial of n over our un is n plus 1 into n plus 2 over the factorial of n. This is equal to n plus 2, n plus 3 times the factorial of n over here is n plus 1. Yes, times n factorial multiply by here is n plus 1. This is n plus 1 and n plus 2. This is credit, this term and this stuff will simplify one another to have what? Here un plus 1 over un. This is, let's do this. We are going to have n square plus this times this, that is 3n, this times this, that is 2n, 3n plus 2n, that is 5n, plus this times this, that is 6, over, here we have, and this is the square of n plus 1, that is n square plus 2n plus 1 times what? Times n plus 2. This is n square plus 5n plus 6 over this, and this is n power 3. This and this, that is n square plus 2. N square, this and this is plus 2. N square, this and this plus 4n plus this and this, n plus 1. Un plus 1 divided by un. And this is n square plus 5n plus 6 over n power 3 plus this stuff is similar to this, that is 4n power 2 plus this and this are 5n plus 1. Taking the limit, n approaches infinity of n square plus 5n plus 6 over n power 3 plus 4n power 2 plus 5n plus 1. And this is seen by finding limit as n approaches 0. We take the highest denominator or numerator, this is n power 2, over the highest denominator on the numerator, this is n power 3. This is the limit of n approaches infinity of 1 over n, simplifying this and this. And this limit is 1 over infinity. And any number over infinity, that is 0. As you see, 0 is less than 1, guys. Here, 0 is less than 1. Since the limit is less than 1, our given series n plus 1 into n plus 2 over the factorial of n is convergent, and this converges to 0, and it converges to 0. Let me remind you that I need you to share the live. You need to subscribe also on my channel. Let's do the next question, which is D. The end of this question D is also the end of our life. This will be the end of our life. Our life is going to end there. The question D, which seems to be the last one, is the sum as n starts from 1 to infinity of 2 to 3 over 3 to 2n. Our general term here, un, will be 2 to 3n over 3 to 2n. The next term from this is un plus 1. And this is 2 to 3 into n plus 1 over 3 to 2 into n plus 1. This is 2 to 3n plus 3 over 3 to 2n plus 2. Un plus 1 is now equal to 2 to 3n times 2 to 3 over 3 to 2n times 3 to 2. Let's have un plus 1 divided by un. This is our un plus 1 is 2 to 3n times 2 to 3 over 3 to 2n times 3 to 2. The un is 2 to 3n over 3 to 2n. And this is equal to 2 to 3n, this times 2 to 3 over 3 to 2 n times 3 to 2. Let's multiply the reciprocal of this. Here will be 3 to 2n over 2 to 3n. Here, un plus 1 over un. This is, as you see, this will simplify this. This simplifies this. Here is 2 to 3 over 3 to 2. 2 to 3, that is 8 over 3 to 2, that is 9. As you see, because 8 is less than 9, this is less than 1. And to be less than 1, and this means that the series, the given series is convergent. Is convergent. Okay, taking the limit n approaches infinite of un plus 1 over un. This is the limit n approaches infinite of 8 over 9. This is 8 over 9 as we saw it here, and this is less than 1. The series converges. The series converges to 89. Guys, this is the end of our life. What I want from you is to share this live. Go on my channel and subscribe on it. Your like, your comments are both crucial to me. Thank you very much, my friends.